Okay, so let's take a look at finding the area of a regular polygon. So it wants us to find the area of a regular heptagon with a side length of 2 feet, and we want to find that to the nearest tenth. Okay, so I'm going to start this problem by drawing a regular heptagon, right? That's 7 sides. Okay, so this looks like it will do. All right. At this point, I may scroll down a little bit. I want to go find my center, which is about right here. Again, this picture is not going to be exact. It's just going to help us solve the problem. Okay, and now I'm going to just draw these segments that go from the center to each of the vertices. Okay, and so I can do this for every single one. There's not, no need to do all of them, but while I'm at it, I guess I can. That one's not very good. I'm going to redo it. Okay, so theoretically, these are all congruent triangles. So if we find the area of one of these and then multiply it by however many triangles there are, that's one way that we could get the solution. Okay, but let's recall that how we actually can calculate this is that the area is going to be equal to 1/2 times the apothem times the perimeter. Okay, and they told us that each of these side lengths are 2. Okay, and so again, these are all congruent, right? These sides are all actually congruent. Okay, now we want to start this problem by finding what the measure of the central angle is. So I'll start with that. So I'm going to say find measure of central angle. Okay, and so I'm going to do that by taking 360, because there's 360 degrees there. I'm going to divide it by how many sides we have in our polygon, which is 7. Okay, and that will give us about 51.4 degrees. Okay, so one of these, and I'm just going to write this one up here. Okay, this is 51.4 degrees. Okay, now remember, all of these are actually the same, so these are all congruent. Okay, these are all congruent. Okay, now what I am going to do is I'm going to erase this one sort of in the middle here, because we're going to use this triangle to find our apothem, right? That's part of our formula here. Area equals 1/2 times the apothem times the perimeter. Okay, and so I am going to sort of just draw a dotted line here from the center, and I'm actually just going to bisect this triangle. Okay, now when I bisect, or when I do an angle bisector here of this triangle, it's sort of assumed that this is 1. Okay, or that each of these are now 1. Okay, and that also that this is a right angle here. Okay, now it's also assumed that if I do an angle bisector, that my angle measure here, if I take 51.4, okay, if I go 51.4 and divide that by 2, this will give me 25.7 degrees. Okay, so I'm going to just sort of color in this blue part here. I'm going to draw an arrow over here and just say that that is actually 25.7 degrees. Okay, now again, I'm really interested in figuring out what is my apothem here. What is my height of this particular triangle? Okay, and that will help me solve this problem. Right, so I want to know my apothem. Okay, it looks like that is the adjacent leg to 25.7 degrees. Okay, I also already have my opposite leg of 1. Okay, so I should be able to use my tangent ratio. Remember, SOHCAHTOA. Okay, so I'm going to use the tangent of 25.7 degrees, and that's going to be equal to my opposite leg, which is 1, over my adjacent leg, which I'm just going to call A, because it's my apothem. And so I'm just going to kind of rearrange this and multiply both sides by A. Those will cross cancel there. Now I can divide both sides by the tangent of 25.7 degrees. So I'm going to get that the apothem is going to be equal to 1 over the tangent of 25.7 degrees. Okay, and I'll see what I get. So I'm going to go to my calculator and take 1 divided by the tangent of 25.7. Okay, and that is going to give us about, I'm just going to write down this, A equals 2.077846524. Okay, now you can just, you can either write this down or you can just keep it in your calculator and don't delete it. right? But this is our apothem, right? This is part of what's going to help us actually solve our problem. Okay, now what I'm going to do is quickly do a little bit of arithmetic and figure out what our perimeter is, right? So I know that each of these side lengths are the same, right? They're all 2. Okay, so that would mean our perimeter here is 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Or in other words, 2 times 7. Okay, it's going to give us 14. Okay, so our perimeter is 14. We just found our apothem. Okay, and so now we have everything for our formula. So what I'm going to do is just say that, I'm going to scroll down a little bit here. Okay, and I'm going to fill in my formula, right? Area equals 1/2 times the apothem times the perimeter. Or in other words, area is going to be equal to 1/2 multiplied by this value that you should hopefully still have in your calculator. Okay, and then multiplied by the perimeter, which is 14. All right, and so at this point, if I still have this value in my calculator, I can, in my head, I know that 1/2 of 14 is 7. So I can just multiply this value that's in my calculator by 7, and that gives me the answer. Okay, and so I would say that my area here is going to be equal to about 14.5, and we are dealing with, it looks like, sorry about that, we are dealing with feet, so square feet. Okay, again, hopefully fairly simple. In the next video, we'll definitely go through one more example, so it's a little bit more comfortable.